Hello all, welcome to the 64-bit edition of the SecurityTube Linux Assembly Expert course and certification. Now in this video, we will look at scanning and comparing strings in 64-bit assembly. The two instructions we will touch upon is scas and comps. So scas basically has scas B, W, D and Q, which stands for really comparison of 1, 2, 4 and 8 bytes. Now this comparison happens with the respective register RAX. So scas B compares a byte with AL, scas W compares 2 bytes with AX, scas D 4 bytes with EAX, and scas Q 8 bytes with RAX, right? And the string which we are comparing is actually going to be referenced by RDI. So let's jump right into the program. Now I have defined three variables. Really var1 and var2 are different, both of them 8 bytes, and var3 is exactly the same as var1. Now if we go up in here, first I clear the direction flag and then I move the value 1, 2, 3, 4 blah 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 into RAX, which is really the same value as var1, and then I load the address of var1 into RDI. After that I call scas Q. Now if both of these match exactly, then the 0 flag would be set. If not, it wouldn't be set. Apart from other flags depending on however the operation happened. Now at the very next statement, I load the address of var2, which is going to be different now from this, and again call scas Q. Now I've called scas Q here separately, but similar to what we did in the previous video, you can use rep, repany, etc. to go ahead and run this inside a loop-like structure. So let's go ahead and look at this. So let's invoke GDB, but before that let's go ahead and use ASM. Let's use LD. And now let's load this up into GDB. Let's set a breakpoint for underscore start. Set the disassembly flavor to Intel. Let's run the program. Layout to ASM. Let's also lay out the registers. And now let's step through the program. Okay, so program is already started. Step I. So we've cleared the direction flag, and now we are moving this value inside RAX. And just to remind ourselves, this value is identical to var1, which is located at this address. Probably have to display this in hex rather than as a string, my mistake. So basically this value is identical as that of RAX. So let's step further. Now notice something interesting. Scas Q seems to be replaced with scas RAX, keyword PTR followed by the address. Now the interesting thing is that internally this is going to be the representation, and for us the shorthand will always be scas Q. So keep that in mind. You will always see scas, and depending on if you use B, W, D or Q, the appropriate pointer type would be selected here. So as expected, in the very next statement when SCAS runs, because both these values are identical, basically we will go ahead and see the zero flag being set. And we can clearly see the zero flag is now set because the comparison succeeds. Now let's go ahead and load up basically the other variable which is going to be different, and we can verify this. Right, and now when we go ahead and run SCAS Q, actually find that the zero flag was not set because they were dissimilar. Fantastic. Now let's go back in here and let's look at the CMPS BWDQ option. Now SCAS really is a comparison between memory and a register, while CMPS is really comparison from memory to memory. So we will reference the source by RSI and the destination by RDI. Really, in this case, it is just the two memory locations which are going to be compared. And after that, we can go ahead and use CMPSQ to compare 8 bytes from the beginning of both these locations. Now, var1 and var3 are identical, which would lead to the comparison succeeding and the zero flag getting set. So let's step I. There we go. And now if you notice, even for CMPS, the Q has been replaced, and here the representation is really the Q word PTR, right? Again, you would find this everywhere. Now take a close look here in the flags, and there we go. We see the zero flag has been set. After that, the last three instructions are really the syscall for exit and the program exits. Now I leave it to you as an exercise to use the rep functionality to probably implement functions like memcompare, string length, and all of that, which you can do using SCASQ, rather SCASB and CMPSB, or any of the other options. So hopefully you've enjoyed this video, and if you like what you see here at Pentester Academy, we would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.